Situation, the horizontal pulley situation. Let me just show it to you really quick, and then we'll do some math, and it will be good. So, yeah, let me get this more towards the center so that everyone can see this. Okay, so you guys okay? See this cart? And this cart has 1,000 grams in it. This is 1 kilogram, alrighty? And we learned yesterday that when I put two masses on a pulley, the heavy mass goes down and the light mass goes up, right? So I'm going to do the same thing here. Here's the heavy mass, 1 kilogram, 1,000 grams, and I'm going to attach it to 100 grams. 100 grams. So here we go. 100 grams. And we learned yesterday that the light mass goes up and the heavy mass goes down. So I'm going to put this 100 gram here, and I'm going to just have it like this, and I'm going to let it go. Okay, just a second. I'm going to let it go, and we would expect this light mass to go up and the heavy mass to go to the left, correct?
It's
To the right, I mean to your right. Do you think that this guy's going to go that way?
No.
No, which way is it going to go? Now, why is it? Why is it that now the light? Whoa. Thanks a lot, Zena. My bad. But so you guys see, I mean, in this case, the light mass is going down and the heavy mass is being moved. Why is it that the light mass is moving the heavy mass? Good. Gravity acting on what? Good. The light mass. And because gravity is acting on the light mass, why is this guy moving? What's exerting the force on this guy?
Tension.
Yeah, tension. You guys okay? The tension. So gravity is pulling down on that light mass. Tension is pulling up on the light mass, which means now you've got tension in this string, and that tension in the string is pulling this car. Okay, great. So let's go ahead and deal with this situation. We're going to deal with it where there's no friction first, and then we're going to deal with it where there is friction next. Okay, so here we go. The situation. Here's the first situation. I'm going to make this guy 1 kilogram. I'm going to make this guy 2 kilograms. And I'm going to say that the coefficient of friction is equal to 0. So there's no static friction, no kinetic friction. Friction is equal to 0. So let me remind you what happened yesterday. Yesterday, we had this situation where this was 1 kilogram and this was 2 kilograms. And it turns out that the acceleration was 1/3 g. And we also had this situation where this was 3 kilograms and this was 5 kilograms. And it turned out the acceleration was 1/4 g. And I don't know if I got the chance to even ask you guys, is there something I could do with these masses really quick where I could have found those answers without having to do that sum of the forces stuff? Did you guys figure that out yesterday?
No.
What was it? Noah, what was the answer?
So if you add the 1 and the 2 kilograms, you're going to get 3 kilograms, and the difference is 1 kilogram, so it's 1/3. And then
Good.
Over there, it's a total of 8 kilograms with a difference of 2, so you can reduce that to 1/4.
Good. You guys okay with that? And did we talk about why that's so?
No.
Okay. Well, hey, I'll tell you, or maybe you'll tell me. Why is it that it's 1/3, 1 on the top and 3 on the bottom? Why is it 2 on the top and 8 on the bottom? Can anyone figure out a physical reason for why that would be so? Like, what does the sum of the masses signify? What's the difference of the masses signify? Yes?
Would it be all the weight on the string or rope?
Good. All the weight. When you say all the weight, are you talking about the sum or the difference?
The sum.
Okay, good. You guys okay? The sum of the masses is what you're accelerating. I'm having to accelerate 3 kilograms of stuff, right? If I think of F equals ma, my m is 3 kilograms here. My m is 8 kilograms. I'm accelerating 3 kilograms. Good. But how about the force? What's the net force acting on this system? You know, and when I say net force, I mean, I don't know, like the net force that's making it accelerate. Yeah.
The 1 kilogram.
Yeah, the 1 kilogram difference, right? Because I've got 1 kilogram here and 1 kilogram here, but if I just had a pulley where it was 1 kilogram here and 1 kilogram here, what would those guys do? Nothing, right? They would just sit there because the 1 kilograms are canceling each other out. The only thing that makes these guys move is because this guy is more than 1 kilogram. And I hope you see that it's the difference of the masses that's providing the force, if you will, the net force, the impetus to make this whole system accelerate. So what's accelerating the system is the difference of the masses. What you're having to accelerate is the sum of the masses. And do you see that's what's happening here? The net force is 2 kilograms. The total amount that you're having to accelerate is 8 kilograms. So it's 1/4 g. How about if I gave you this? Here, I'll give you one really quick. What if this is 2 kilograms and this guy here is 7 kilograms? Okay. What would you expect the acceleration of this guy to be? Yeah, good for you. 5/9 g, right? 5/9 g. All right. So here's my next question to you. What do you expect this to be? The friction is 0. What do you expect the acceleration of this system to be? Let's have some. Raise a hand so I know who to call on. What do you think? Give me a number. No one one person last period figured it out, but he was too afraid to say. So I don't want you guys to be afraid. Give me a fraction of g. Oh, please, someone raise their hand. I thought I heard fractions. What fraction of g do you think this acceleration is going to be? Yes. Justin says 2/3 g. Does anyone agree with him? Noel does. Does anyone have an alternate answer besides 2/3 g? Really? Okay. All right. Anyone thinking 1/3 g? Like what happened here? This is 1/3 g. Why shouldn't this guy be 1/3 g? Yes?
His gravity is not acting on the 1 kilogram.
Good. Yeah, gravity's not keeping this guy from moving, right? Well, let's go ahead. So how many people think it's 2/3 g, which is what Justin thinks? Okay, so a couple of you are convinced. Good. Good, un-American people. Convinced by reason, un-American. Okay. Well, let's go ahead and do the problem. And the way you do problems like these, again, is just like any pulley problem. Do a free body diagram of both masses. That's your key. So let's go ahead and do that. And I'm going to go through it pretty quickly. And then I'm going to do a situation where there's friction. And then I'm going to give you guys one to do on your own. So here we go. First of all, I got to do a free body diagram of both masses. So here's the 1 kilogram mass. There's normal force. There's its weight, which is 9.8 newtons. There's tension, and no friction force, so I don't have to put a friction force there. I'm going to define up as positive and to the right as positive. This guy is accelerating to the right. Okay? And so I'm going to do sum of the forces in the y direction equals may. I hope you see that there's no acceleration in the y direction. So I got normal force minus 9.8 newtons equals 0, or I get normal force equals 9.8 newtons. Yay. By the way, why do I not need what the normal force is? Why do I not care what the normal force is in this problem?
There's no friction.
Thank you, because there's no friction. So there's no mu sub kf sub n or mu sub s sub n. Okay, let's do some of the forces in the x direction equals max. The only force I have happening in the x direction is tension. The mass is 1 kilogram times the acceleration. And there it is, T equals 1A. Now I'm going to do a free body diagram of the 2 kilogram mass. Oh, I shouldn't go so low, sorry about that. Here's the 2 kilogram mass. Free body diagram, tension up, 19.6 newtons down because it's a 2 kilogram mass. And the acceleration is downward. And I'm going to define up as positive. So when I do sum of the forces in the y direction equals MAY, I got tension minus 19.6 newtons equals 2 kilograms times, I'm going to get a drink of water. What should I put in those parentheses? Should I put A or negative A? Hopefully you all see it's negative A because I'm accelerating downward. I've defined up as positive and I'm accelerating downward, so it's going to be negative A. What if I find putting a negative A offensive? There is something I could change about this drawing where this would be a positive A. What could I do?
Meant 19.6.
Say again?
19.6.
No, it already is negative. What can I do here? Yeah, go ahead, Sean.
Define down as positive.
Yeah, thank you. Define down as positive. You define down as positive, and now this will be 2 times positive A. It's just what's going to happen to the left side if down is positive. Yeah, they get switched, 19.6 minus T. And that's fine if that's the way you like to roll. I don't, it's up to you. So I got T equals 19.6 minus 2A. Now I'm going to put these guys together. So I have A equals 19.6 minus 2A, or 3A equals 19.6, or A equals 1/3 G, right? 19 points, or rather, excuse me, I'm so bad. 1/3 times 2G, because 19.6 is 2G, or 2/3 G. So was Justin and Noel and DeAndre? You're DeAndre, right?
Yeah.
Sorry.
I think so.
Yeah, I'm having some real trouble with names today. Were they correct? Sure, 2/3 G. Okay, now let's go ahead and do a problem that involves friction. Here comes our next problem. We've got 2 more problems to do. Here's one, oops, that involves friction. Just 1 second. Example number 2. And this is now going to be 2 kilograms here. This is going to be 1 kilogram there. The coefficient of static friction is 0.60, and the coefficient of kinetic friction is 0.40. I'm going to ask 2 questions. Number 1, does it move? And number 2, once put in motion, find the acceleration. By the way, what if there was no friction whatsoever? What would you expect the acceleration of the system to be if there was no friction whatsoever? Good. Many of you are getting 1/3 G. 1/3 G. I got 1 kilogram doing the accelerating, accelerating the system, but I have 3 kilograms that have to move, that have to be accelerated. 1 kilogram provides the force, 3 kilograms to be accelerated, that's 1/3 G. Okay, great. Well, hey, let's go for it. And again, just like always, you're going to do a free body diagram of both of these guys. So let's do it. We're going to do part 1 first. Does it move? So here's my free body diagram. I've got normal force up. I've got 19.6 newtons down. I've got tension acting this way, and I've got static friction force opposing it. And if I want to know if it moves, then I need to see if tension can overcome the maximum static friction force possible. So I'm actually going to label this static friction max, because I need my tension to be greater than the maximum static friction force. And by the way, if I'm trying to find if I have enough tension to break all the bonds but not set it in motion yet, but just break all the bonds, what's the acceleration of this system going to be? Yeah, 0. We assume 0 acceleration when we're just trying to break the static friction bonds. So I'm going to do sum of the forces in the y direction equals MAY. I got normal force minus 19.6 newtons equals 0, or normal force equals 19.6 newtons. Good. I think that's pretty easy. Now it's time for us to do the sum of the forces in the x direction. Sum of the forces in the x direction equals MAX. Tension minus the maximum static friction force is equal to 0. And so the tension is going to be equal to mu sub s f sub n. Tension is equal to 0.60 times 19.6 newtons. So my tension has to be 0.6 times 19.6, 11.8. Alrighty. So let me ask you, I need a tension of 11.8 newtons or greater in order to make this thing move. Am I going to be able to make this thing move? I see a few people shaking their heads. Can this move? Is this guy providing enough tension for me to move this mass? Okay. So who would like to tell me, someone, even though I love you dearly, Noel, but I want someone else to have a chance? Why? I see several people shaking their heads and nobody nodding. So one of the head shakers, why is it not going to move? Can't I get 11.8 newtons of tension? Remember, the tension's being provided by this guy. Good, Fatima.
Because the weight of the 1 kilogram is only 9.8.
Thank you. The weight of the 1 kilogram is 9.8. The most tension you're going to get out of this is 9.8. When everything's, static, when nothing's moving. Yeah, so the most tension you're going to get there is 9.8. You need 11.8. It's not going to move. So let me write that down. Most tension that the 1 kilogram mass can provide is 9.8 newtons. Not enough. Oops. No movement. Okay. Can I demonstrate that sort of thing? Here, suppose I want to move this 1 kilogram mass, and I use 20 grams. Is 20 grams enough to move it? Here. Nope. 20 grams will not move it. Now, what if I give it a little push so that it overcomes static friction and now it's put in the kinetic friction situation? Will it move now? Still not enough. So not only do I have enough tension to move it from the static friction situation, I don't even have enough tension to move it from the kinetic friction situation with 20 grams, but how about 30 grams? Now I put 30 grams on here, and see, here, let me just do it. Okay, from the static friction situation, it does not move. But if I give it a little push, now it moves. Let's give it another push. Not a stupid thing. It worked last period. Well, let's put 40 on there. 30's good, 40's better. But I'm afraid 40's going to overcome the static friction situation. Okay, let's see 40. No, 40 seems to be overcoming the static friction. Yeah. Well, anyway, you get the idea. You can have I'm hoping, you have a situation where you don't have enough tension to overcome static friction, but you do have enough tension to overcome kinetic friction. And that's what's going to happen here. So let me do the rest of this problem, and then we'll do the next one. Okay? Step 2. Once put in motion, find A. Now we've overcome the static situation, and we're going to turn that into kinetic. So to do part 2 now, my free body diagram of the 2 kilogram mass is going to be 19.6 newtons, normal force, tension, and kinetic friction force. As before, you're going to get normal force equaling 9.6 newtons. That's not going to change, but the X stuff is going to change. Some of the forces in the X direction equals MAX. I've got tension minus mu sub K F sub N equals 2 kilograms times A, or tension equals 0.40 times 19.6 plus 2A. So that's one equation. Now I'm going to consider the 1 kilogram mass, which has tension down and mg down, tension up and mg down. This is 9.8 newtons. And this thing's accelerating downward, but we've defined up as positive. So the 1 kilogram mass, I've got tension minus 9.8 equals 1 kilogram times A, or tension, and by the way, is that A or negative A? Yeah, negative A. Negative A. So I got to 9.8 minus A. Great. And now I can put those two things together. I get 0.4 times 19.6, which I think is 7.84. I did it last period. 0.4 times 19.6, 7.84. 7.84 plus 2A equals 9.8 minus A, or 3A equals 1.96, or A equals approximately 0.65. You guys okay with that process? So you're finding maximum friction force, which is also going to be the tension required. You're going to see if your other mass will provide that tension. And then if it does or doesn't, you give it a push, and then you go through this process. Also, do you notice how this guy, if coefficient of friction was equal to 0, my acceleration would be 1/3 g. That is, my acceleration would be, you know, approximately equal to 3.27 meters per second squared. But instead, when the kinetic friction is 0.4, my acceleration is only 0.65. So I want you to see what a big difference, what a big effect kinetic friction had on the system. You give it some friction and boom, it's accelerating way less than before. Hey, you guys ready to do one of these on your own? Yes. I'm hoping so. I'm not sure if you guys are down with this, but let's do it. kilograms. This is 1.5 kilograms. U sub S is equal to 0.70, and U sub K is equal to 0.50. And again, will it move? And then get the acceleration. Good luck, you guys. I'll give you about 5 minutes. And then I'll quickly give you a heads up on number 16. That's really strange. You know what I find weird about this problem? How often is the quotient of two numbers equal the difference of two numbers? Do you notice that? 4.9 divided by 3.5 equals 4.9 minus 3.5? Now that has to be a really rare occurrence, wouldn't you think? I don't know, I've never thought about it, but whatever. Hey, time is kind of running out. First of all, is this thing gonna move? Do I need to push it? No way, because my maximum static friction force is 13.72, which means my tension has to be at least 13.72. Well, what's my tension gonna be if everything's just not moving? 14.7, right? The weight of this object. So, no need to push, it's gonna move on its own, T equals 14.7 newtons, so it moves. That's if nothing's moving, it'll move. Once it starts accelerating, then your tension actually reduces, and you could plug back in to find your tension. But I just want you to see that your maximum possible tension is greater than static friction, so it will move. Hey, how many people got 1.4 as the answer? Okay, several of you. Is there any question or issue on this? Just, you're gonna get, I think, 1 or 2 problems like this tonight, and all I can recommend is just go through the process. Do free body diagrams of both of these. Just remember that the tensions are the same and the acceleration magnitudes are the same, and you should be fine. Yeah. Well then, hey, I gotta give you a quick heads up on number 60, and then we're done. Problem 60 is not difficult physics-wise. Problem 60 is difficult mathematically. Problem 60 is going to make demands on your ability to do algebra. So I need to give you this heads up. I got to show you something I've never shown you before. Here's a problem like number 60. This isn't actually number 60. Suppose I have a sign. It's a 20 kilogram sign. It's being held up by 2 cables. One cable here at a 60-degree angle from the horizontal, and one cable here at a 20-degree angle to the horizontal. Okay? These 2 cables being at 2 different angles are going to be 2 different tensions. This tension, which I'll call T1, and this tension, which I'll call T2. By the way, which of those tensions do you think is going to be greater, T1 or T2? Let's have a vote. How many people say T1 will be the bigger tension? Okay, many of you. How many people say T2 is going to be the bigger tension? Just Noel. Okay, Noel, why do you say T2?
Because the angle is greater, meaning that, well, because like when you have a 45, 45, 90, isn't the hypotenuse just like x rad 2? And then when you have a 30, 60, 90, isn't it like rad 3 or something? And rad 3 is greater than rad 2.
Okay. All
Oh,
right.
no, it's 2 times x. I don't actually know what the number is, but I think it's greater. I don't know.
Okay. Can I give you a limiting situation? Instead of this guy being like this and this guy being really like this, how about the limiting situation? This guy is like that and that guy is like that. Now, which of those 2 wires is holding up the sign? This guy, right? He's doing all the work. This guy's just sitting there doing nothing. Well, do you see that this is similar to that? This guy's going to do more of the work. Okay, I need to really quickly show you how we're going to do this. Yes, and let's see, Sahara, you need to leave. If you wanted to leave, be my guest. Okay, so here's what you're going to do. You're going to get the x and y components, but the difference is you need to express them in terms of only one variable, T1 and T2. And here's how you're going to do it. This is a 20-degree angle, right? So are you okay that the sine of 20 degrees equals ty over t1, t1y over t1, which means t1 sine of 20 degrees equals t1y. So you're not going to call this t1x and t1y and t1x like you did yesterday with the helicopter problem. You're actually going to, because that's two separate and distinct variables, tx and ty. No, you're going to call this t1 sine of 20, and you're going to call this t1 cosine 20, because it's similar with the cosine. And the same thing here. This is t2 cosine of 60 degrees, and this vertical guy will be t2 sine of 60 degrees. So now you've only got two equations, or rather, I'm sorry, you've only got two unknowns to go with your two equations. In fact, let me go even further. If the bell rings, I apologize, but don't go anywhere. Here, I'm going to have t2 cosine of 60 minus t1 cosine 20 equals 0. When I do the sum of the y, I forgot to do this, and I'm just really zipping through this. Sum of the y equals 0. So I've got t1 sine 20 plus t2 sine 60 minus 196 equals 0, right? I now have two equations with two unknowns, and the technique you're going to use is substitution, like solve for t2, where t2 equals t1 cosine 20 over cosine 60, and you can figure out what that is, and that's like about 1.9 if I remember correctly. So now I've got t2 equals 1.9 t1, and now you can plug that in right there and solve for t1. So this is the way you're going to do number 60. You're going to not call it t1x and t1y, t1y and t1x. You're going to call it t1 sine 20, t1 cosine 20. So you've only got two unknowns, t1 and t2. Good luck. Good luck.